Although every area of life is becoming ever more digitalized, vinyl is still the favorite medium of many DJs. A majority of them is still keen on analog sound and prefers the surface feel of vinyl. It simply feels better than a CD or MP3 data on hard disk. But how is a vinyl disc manufactured? The following report will try to shine a little light on the process of manufacturing a record, from the finished cut and mastered foil in the mastering and cutting studio, right up to the finalized record. In Germany, foils are cut by cutting studios such as Rand in Leipzig or Dub Plates and Mastering in Berlin. Correct mastering in advance is very important, as the tracks are optimized to the maximal level and optimal frequency spectrum that can be reproduced on vinyl. No wonder that some specialists have achieved cult status because of their mastering and cutting talents. In the cutting studio, the grooves containing the information are cut into the master foil by means of a stylus. The master foil, the so-called acetate, consists of an aluminium disc that's coated with acetate lacquer. Foil cutting is a separate and very complex process, which we won't go into in detail here. We're going to concentrate totally on the manufacturing of a vinyl record. Electroplating is the first stop at the pressing plant. The foil is brought here from the cutting studio to be prepared for electroplating. To improve contact and conductivity, a piece of foil is removed from the back around the center hole. Afterwards, the central area of the disc is roughened so the label won't tear or slip during pressing later on. Then the foil is rinsed with demineralized or deionized water. Rinsing is very important to remove unwanted residues and other substances from the foil. Then the foil is dipped in a degreasing fluid to remove or at least reduce the foil's own gas emissions and any finger marks. The degreasing fluid mainly consists of potassium hydroxide. Afterwards, it's rinsed again. The next step is necessary to enable the formation of a cohesive aquatic monolayer on the foil. The foil is then wetted in 3 different baths and so prepared for silvering. The timing is very important here. If the foil is left in the preparatory solutions for too long, the background noise of the vinyl might increase. If it's taken out too early, however, the record might crackle. Rinsing is very important after every stage, because some new residues accumulate on the foil every time. In the so-called silver plating cabinet, the foil is now attached to a turning knob. A small amount of wetting agent is sprayed onto the surface once again to prevent the surface film from breaking during the silvering process. After that, a mixture of silver solution and reduction solution is applied. This mixture reduces itself to a layer of silver film on the foil surface, less than 1 micrometer thick. Without the preparatory steps, the silver film would develop much more slowly and wouldn't be so consistent, which would lower the sound quality dramatically. Here's an example of how it would look if the foil wasn't correctly pre-treated. There is no cohesive monolayer on the foil surface, and the water forms beads. So let's get back to the correctly silver-plated foil. The residues on the back are removed with a sponge before the foil is rinsed again. Cleaning is very important because undesired substances may compromise the galvanic bath and make it unsuitable for the next step. The foil is now brought to the so-called pre-electroplating. Beforehand, a rubber ring is put round the edge. This will ensure that the nickel coating, which is developed during the electroplating process, can be easily separated from the foil. Now the foil is dipped into a nickel sulfamate solution. An electrochemical process takes place. Here the cage with the nickel balls inside is the positive pole, called the anode. When subjected to DC current, the nickel ions migrate to the silver plate, the cathode in this case, and accumulates as a metallic nickel plate. In the pre-electroplating bath, relatively low amperage and temperatures are used. With higher amperage, the nickel plate can generate internal mechanical tension, which would possibly distort the groove of the foil surface. The foil now remains at the pre-electroplating for approximately 1.5 hours. After that, it's put into the main electroplating process, where the nickel plate grows to its final layer of thickness, which is about 200 micrometers, 0.2 millimeters. In the main electroplating process, high temperatures and amperage are used. Therefore, the nickel accumulates more quickly than in the pre-electroplating process. The layer thickness is always a result of time and amperage. When electroplating is finished, the newly developed nickel plate is separated from the foil and is now called the negative. Since no further replicas can be made from the foil, another step is necessary. The complete electroplating process is repeated with the negative. At the end of this process, the positive is developed, the so-called mother. From this mother, several negative copies are produced, which are also called sons or stampers, and are used as pressing templates. One template is good for manufacturing approximately 1,000 discs. With this, the electroplating process comes to an end, and the first negative is prepared as a mould. To manufacture the mould, the back of the template is ground with very fine emery paper in order to remove the microscopic roughness on the surface. As the central position of the hole gets lost during electroplating, the template is put into a centering device where it's centered on its exit groove. The disc has a lateral tolerance of 0.2 millimeters. If the centering isn't exact, the disc will not rotate correctly. Now the surplus edge of the template is cut off, making the mould smaller. In the final step, a profile is formed at the edge and within the central area of the template, so the template can be mounted exactly in the vinyl press. The finished stamper is clamped into the mould of the unit. For each side, one pressing matrix is required. Then a granulate of a synthetic PVC compound in viscous form is put into the so-called extruder and formed into small vinyl cakes, which are put into the press. The cakes weigh about 160 grams and have a temperature of 160 degrees Celsius. The mould is steam heated to 180 degrees, which liquefies the vinyl cake. With the use of hydraulics, the press tools compress the vinyl cake at a pressure of 110 tons. In this way the grooves are pressed into the vinyl, and by means of the groove guard profile, the round form of the disc emerges. The two labels per disc are added from the side in the same procedure and pressed onto the vinyl. After that, the press tools are flushed with water to cool the newly emerged vinyl disc. The pressing procedure with heating up and cooling down takes approximately 22 seconds per disc. Now the excess edges of the disc are cut off in order to reduce the disc to its final size, in this case a 12-inch. The cut-off vinyl edges and the discs in general are recyclable and can be melted down and newly pressed several times. However, the quality gradually diminishes. The vinyl disc has a final weight of approximately 140 grams. For quality control purposes, single discs are taken randomly off the press for sampling. They're checked visually and for sound quality. Finally, the discs are packed and prepared for shipping. For the huge steam boilers, heat exchangers, hydraulic devices, oil aggregate and cooling towers, which are all necessary for operating the unit, a lot of space is required. As cool as it may sound, a vinyl pressing plant at home is impracticable for all these reasons.